Hey everyone, this is Big Face from Big Face Robotics. I found a couple of hours to do some more work on the RC robot. You'll remember from the last video I've got the Raspberry Pi taking data via the Bluetooth module from the transmitter, and that's connected to the Arduino on the robot, and I'm gathering up some sensor data from that as the robot drives around and sending it back to the Raspberry Pi to be logged. So I've been doing a bit of work and I'm at the stage now where I am getting some data back to the Raspberry Pi, and I've sorted out some issues with the serial comms, particularly when grabbing frames from the webcam. I wasn't reading the serial data fast enough from the transmitter or back from the Arduino, so I had to do a bit of work to sort that out and discard any old data. Or read all the data in the buffer and get rid of the old stuff. So this is now working. I'm almost at a stage where I can put the robot back together and give it a test run and see what the data looks like I get from the robot as it's driving around. So a quick test before I put the robot back together. I've set the Python script to auto run on the Raspberry Pi when it starts up, and I've got the controller here. You can see I've still got control of the robot, and I've also programmed it so that when I click this left joystick it will start recording on the Raspberry Pi. And keep an eye on this LED here, it should turn red. There we go, it's gone red, so now I'm recording video and capturing data from the robot, and I'm just on the joystick, and as you can see the wheels are still responsive, it's all still working. I'm recording the data, and if I click again, you'll see that LED go back to green, and that means the data has been stored and is there to have a look at. So let's see what that looks like. Okay, so I thought I'd just run one more quick test. I'll show you what that's doing on the screen to save the data. Every time I click record, I create a time-stamped folder, and inside that folder there will be a video of what the webcam has recorded. There you can see the camera's obviously pointing at the wheel. I thought I'd do that just so there's something interesting to look at, something moving in the frame. And that's the extent of the video that we just captured then. And next to that there is a text file with all of the data from the sensors logged in that file. Now I'm logging a packet of data every time I capture a frame of video. So for each image in the video there is some data to go along with it. I thought that was a reasonable way to try and keep things synchronized for later use. So that's all working, which is nice because that means I can pop the robot back together and collect some video and some data while the robot's driving around on the floor. forgot to charge the batteries. So with the robot put back together and the batteries fully charged, I took the robot back out into the garden and did a lap while recording video and data from the encoders and the MPU 6050. You can see this on the screen, and in the bottom left hand corner is the webcam video being captured by the robot. So you can see the robot followed the path around the garden and ended up doing a full lap and finishing up where it started. So I also captured some data of the robot driving a square pattern on the garage floor, and you can see that happening here. And again, I was capturing the data and the webcam stream. So in order to do something useful with the data, I wrote a Python script, and you can see that on the screen here. First job was to open up the directory where the data was stored and set an initial X and Y coordinate position. I then used OpenCV. I created a window and a new empty OpenCV image, in this case 3 channels and 1000 by 1000. I then opened the file for the data file for reading, and for each line in the data file I grabbed the data as a string and converted it to its various integer values. I used the yaw value captured from the MPU 6050 along with the encoder values, and calculated, using that angle and a distance, a new X and Y coordinate. I then drew a line from the current X and Y position to the new X and Y position, and then saved the new X and Y as the current X and Y. I then show the image on the screen, and when I fire that up, I get something like this, and this was for the square pattern drawn on the garage floor. So as you can see, not too bad, a reasonable representation of what happened. I then loaded up the garden lap, and I was pleasantly surprised by the accuracy of the data and the resulting plot. And as you can see from this on the screen now, the lap does actually join up at the end, and is fairly accurate. So I then took the robot into the house and drove a couple of laps around the living room, various other parts of the house, and then plotted the resulting path from the data collected. And this is when things started to go a little bit wrong. I started to see accumulated errors, and the path didn't really look like the path taken by the robot. So whilst the data is reasonably accurate over short duration runs and runs with not lots of turns, you can see the accumulated errors coming in on a route like this. So then, for a bit of fun and another test, I tried to spell out the initials BFR with the robot on the garage floor, and this is the resulting plot. And as you can see, it's not too far off. So over short durations, the data is actually quite accurate. So maybe it's encoder values that are causing the problem. So I'm going to do a bit more work on this in the future with the data collected. So there we go, a successful test. I've managed to collect some good data as the robot's been driving around, and I'm really happy with how this project has gone, and it was great fun as well. Really happy with the homemade RC transmitter. I'm going to be using that again in future projects. Overall, this robot came together quite nicely. There's a few things I would do differently, but generally it's worked, and the data I've got from driving it around is looking reasonably accurate. Particularly impressed with the worm drive gearboxes. They've held up well. Not the most sturdy things in the world, but after 3, 4, 5 hours use now, they're still going strong, so happy with that. And I really like the setup I've got going with the Arduino and the Raspberry Pi. The communications, everything's working nicely. So so yeah, really happy with that. For a minute I've made a decision. I'm going to retire the RC robot project for a minute and move on to a different robot design. Still a mobile robot, but that's coming soon. I'm working on a design and collecting the parts for that now. But for now, the RC robot is. I'm not going to be working on this for a minute. But come back and have a look at what I'm doing with the new robot design. Going to use a lot of the same components, similar setup, just a slightly different chassis for the robot. So that's it for this video. Thanks for watching, and come back soon.